advancement and new business opportunities. Aging assets and lack of circuit capacity. Most of the assets in this country are 40 to 50 years old. They require quick replacements. And power network design life is need of replacement, which is the biggest challenge. The capital cost of like-for-like replacement will be very, very high. Security of supply, need reliable electricity supply as more and more critical loads are connected. Thermal constraint, transmission and distribution lines at its limit. Most of the lines are congested or overloaded. Reduction in the life of the equipment. Increasing incidence of fault. We experience frequent fault at different corridors given extreme loading conditions. Operational constraints, voltage and frequency limits, uncertainty of renewable energy sources. And now coming back to, so this is what the whole history behind the conventional energy grid, the current status, challenges that energy grid poses today, and what we are aiming in next 5 years, that is 2021, what kind of energy growth we are expecting, what type of sources, especially the integration of renewable energy, as well as in 2040, we have to add actually huge amount of energy sources across different energy mix, starting from thermal, nuclear, hydro, renewable, all segments the energy installation has to grow, though the majority may be from renewable energy sources. But what do we understand? Because this is anyway grid. So the question is, are we currently operating an energy grid which is not smart enough? Or what do you understand by smart grid? Or what makes a grid smart? The digital technology that allows for two-way communication between the utility and its customers, and the sensing along the transmission lines is what makes the grid smart. According to customer perspective, if you already manage activities such as personal banking from your home computer, imagine managing your electricity in a similar way. For example, customers will no longer have to wait for monthly statement to know how much electricity he or she uses. With a smarter grid, he can have a clear and timely picture of it through smart meters. Can able to see how much electricity you use when you use it and its cost. Means, combined with real-time pricing, this will allow you to save money by using less power when electricity is most expensive. Means you can organize your consumption pattern based on the energy cost, time of use energy cost, so that your monthly energy bill can be made minimum as possible. Smart grid has the potential to help you save money by helping you to manage your electricity and choose the best times to purchase electricity, and you can save even more by generating your own power by putting rooftop solar. Now the NIST, National Institute of Standards and Technology, provides you the pictorial view of how the smart grid conceptually works. Now we can see there's bulk generation, and we have transmission, then distribution, and customers. Now we can say this is my operating center, and we do have energy market, and we do have service providers. Now the very interesting part, that the thick lines you could see, which is between operation to bulk generation, transmission, distribution, customers, the secure communication interface. And whereas these are the dotted lines, the yellow dotted lines shows the electrical interface, and these clouds are nothing but my domains. So this is how the smart grid conceptually work, taking care of electrical energy flow interface as well as communication interface. So this energy and communication interface together perhaps conceptualize the smart grid operation. Now let us understand the standards of different standards of smart grid definition. Now the first one, European Technology Platform for Smart Grid in 2006 defines a smart grid is an electricity network that can intelligently integrate the actions of all users connected to it, generators, consumers, and those that do both, in order to efficiently deliver sustainable, economic, and secure electricity supply. A smart grid employs innovative products and services together with intelligent monitoring, control, communication, and self-healing technologies to it. It is mainly to better facilitate the connection and operation of generators of all sizes and technologies, allow consumers to play a part in optimizing the operation of the system, provide consumers with greater information and option for choice of supply, significantly reduce the environmental impact of the whole electricity supply system, maintain or even improve the existing high level of system reliability, quality, and security of supply, maintain and improve the existing service efficiently, foster market integration towards modern energy systems. Now let us finally understand the definition of smart grid in precise way. Now US Department of Energy, DOE, defines smart grid in the following manner. Grid 2030 envisions a fully automated power delivery network that monitors and controls every customer and node, ensuring two-way flow of information and electricity between the power plant and the appliance and all point in between. This is what the definition of smart grid by DOE. Now, based on International Electrotechnical Commission (IEC), the smart grid is a developing network of transmission lines, equipment, control, and new technologies working together to respond immediately to our 21st century demand for electricity. Dear listeners, the smart grid definition vary, but as a whole, the outcome of each definition remains same. The main intention here is to establish a strong communication, two-way communication, or two-way flow information between the power plant and appliances has to be established to make your grid smarter. Now, the major duties of smart grid is more efficient transmission of electricity, quicker restoration of electricity after the power disturbances, reduced operation and management cost for utilities, and ultimately lower power cost for consumers. Reduced peak demand, which will also help lower electricity rates. Increased integration of large-scale renewable energy systems. Better integration of customer-owned power generation system, including renewable energy system. Improved security, and if you now come to a reasonable conclusion to compare how the existing grid look like and how do we see the future smart grid will look like. Now the existing grid, it is completely electromechanical and partially digital, where smart grid is expected to be completely digital. Existing grid do have one-way communication, and the smart grid may have two-way communication. Existing grid has centralized generation. Smart grid will have distributed generation. Existing grid has limited sensors, and smart grid will have sensors throughout. Existing grid is of manual monitoring, and smart grid will be self-monitoring. Existing grid may come across failures and blackouts, but smart grid will convert them into adaptive and highlighting mode of operation. Existing grid will have limited control mechanism, and the smart grid will have pervasive control mechanism. And existing grid achieve manual restoration, and smart grid is expected to have self-healing mechanism. Now finally, let us have a look to the smart grid architecture. Now in the smart grid architecture, we'll have the main energy management system. Now we could see that the distribution stations taking power from solar, energy storage, and we could also see the wind power plant. They all constitute renewable energy sources. And then we can experience hydropower generation, and through underground cable they can be interconnected to the same energy management systems. The energy from thermal, nuclear, other source of energy, and these are all our smart houses. So we expect the smart grid architecture will wonderfully connect all residences, electric vehicles, cities with renewable energy sources through an efficient energy management system. So this is what we expect. The smart grid components are of the major components of smart grid are classified as follows. We will have smart infrastructure, smart communication, smart management, as well as smart protection systems. Now the smart infrastructure system is further divided into two parts: smart energy system and smart information systems. The smart energy system will be of power generation type, transmission type, and distribution type, whereas the smart information system will have smart meterings, sensors, pressure measurement units, as well as information management. Now, with this, we stop at our first lecture today, and in the next lecture,